7.3. The central limit theorem for sample proportions. Identify the conditions needed to apply the central limit theorem for proportions. Use the central limit theorem for proportions to describe the sampling distribution of a sample proportion and to find its probabilities. This is 7.3. Central limit theorem is used to estimate proportions in a population. Tells us that if some basic conditions are met, the sampling distribution of a sample proportion is close to the normal distribution. So if we get a sample here, it's a way of telling us if a sample is going to be truly representative of the population, basically, assuming that there's certain parameters here we have to check for. So if we take a random sample from a population, if the sample size is large and the population size is much larger, then the sampling of distribution of p hat is approximately normal within a mean of p. Okay. So the sample is going to behave like a normal distribution if it's large enough. And with a mean and a standard deviation of here. So looking at the standard error, if the sample size is large enough, the standard error becomes very close to what the population standard deviation would be. So if you don't know the value of p, population parameter, you can always substitute the value of the sampling proportion here, p hat. So in most problems they'll give you p. Okay. Conditions for the simple logic theorem for a sample proportion here. Sampling is random and independent. A large sample has to be large enough. Sample size is large enough so the sample expects at least 10 yeses and 10 failures. Okay. A big population, if sampling is done without replacement, the population must be at least 10 times larger than the sample size. Central limit theorem for sample proportions. A picture. This gives a picture of a sampling distribution here for 10,000 samples of size 10 drawn from a population with p equal to 0.25. Note that this does not satisfy the condition 2. The sample size is too small and the distribution is not normal. So they have very small sample sizes here, and this is what happens. But we saw earlier that what happens when you increase the sample size, because it takes almost a perfect bell curve. And the next one here shows the sample distribution of p hat for 10,000 samples. Each sample has of size 100. Notice how here it's almost a perfect bell curve, all from increasing the sample size. Note this here does satisfy the sample size condition of the central limit theorem, and the shape of it is approximately normal. The standard deviation or standard error is right here. Let's look at an example. According to staticbrain.com, 59% of vegetarians are women. Suppose that a random sample of 500 vegetarians is taken. What is the approximate probability that the proportion of females in our sample will be more than 63%. In this case here, check conditions. The sample was random and independent. Okay. A large sample size. Probability of yeses and the probability of nos is more than 10. So to give us that, probability of yeses and the nos is more than 10. We can assume at least there are 10 times that for the sample, at least 5,000. Okay. Since these conditions are met, it will be normal with the standard error being here, given here. Okay. So remember, the standard error here deals with the variation within the samples, like a standard deviation between the samples. Find the probability that the proportion of the sample is greater than 63%. We use technology to find the probability of getting a value larger than 0.63, given this a mean of 59 and standard deviation of 0.022. Okay. So, normal distribution uses StatCrunch, 59 for deviation, 59 for my mean, and deviation 0.022, which is in values greater than 0.63, and it gives us the area. In this next example here, we have voting. Polling indicates that 50% of voters are in favor of the bond and 50 are against. Suppose a random sample of 80 voters is selected. What percentage of the sample would we expect to favor the bond? Does the central limit theorem apply? What is the standard error for this sample proportion? If so, what is the approximate probability that the sample proportion will fall within two standard errors of the population value of p hat? Okay. Because we have a random sample, we expect the sample proportion to be about the same. So we would expect 50% to favor the bond. Okay. We have a random sample here. So we expect 40 here. That's 40. And that's more than 10. And then 1 minus p is going to be 40 as well. It's more than 10. The sample is large enough. We will assume that there are more than 800 voters in the district, so the population size is at least 10 times larger than the sample size. The conditions for the CLT are met. So the standard error is here, which would be p times 1 minus p divided by n. Since the central limit theorem applies, you can use the normal model. Okay, where we're given our mean and a standard deviation. Okay. By the empirical rule, remember that we know that the probability that the sample proportion will fall within two standard errors is 95%. So probability that it falls within 2 deviations is going to be 95% here. So they have the mean here plus, looking at data, the mean plus 2 standard errors gives one end of it, and the mean minus 2 standard errors gives it the other mean, the other end of it here. So now we do a between on those. And the area that corresponds to that is 0.95, approximately 95% of the data. But we also know that from the empirical rule. This is a key point here. If the conditions for the central limit theorem are met, the probability that a sample proportion will fall within 2 standard errors of the population value is 95%. According to American Veterinarian Medical Association, 36.5% of all Americans own a dog. Suppose a random sample of 200 Americans is taken. Would it be surprising to find that 45% of the sample owned a dog? Why or why not? Check the conditions for the use of part of the central limit theorem. It's given that it's random. They told us that at the beginning. We have more than 10 yeses and more than 10 nos. Population here is more than at least 10 times larger than the sample. So the distribution of the sample proportions will behave as a regular normal distribution with a mean of 36.5 and the standard error here of 0.034. Okay. So the mean plus 2 deviations would be 4.433, and that's more than 2 standard errors from the mean. That would be surprising. It's going to be outside that interval. Next up is estimating the population proportion with confidence intervals.